solutions to those quadratic equation exercises. First up, we're going to solve by factoring. So we have 6x squared equals 11x minus 4. We need to get this into standard form where we get everything on one side of the equal sign, 0 on the other. So I'll start by subtracting the 11x and adding 4 to both sides to get 6x squared minus 11x plus 4. Next step is to factor. Notice there is not a greatest common factor, so I will have to use my trinomial method. So we look for the two numbers that multiply to get 6 times 4, which is 24. That adds to negative 11, and that's going to be negative 8 and negative 3. So I'll rewrite this as 6x squared minus 8x minus 3x plus 4. And I will factor this by grouping. I need to make sure that there's a plus sign in between, so I'll rewrite that as plus a negative 3x. And I'll group my first two terms together, group my second two terms together, and factor each of those. Here there's a common factor of 2x. Here we'll pull out a negative 1. Now notice both of these have a 3x minus 4. I'll factor that 3x minus 4 from both of those, and I'm left with 2x minus 1. Now I have this quadratic in factored form. I can solve by setting each factor equal to 0. The 3x minus 4 equals 0, and the 2x minus 1 equals 0. Add 4 and divide by 3 to get 4/3. Add 1 and divide by 2 to get 1/2. So the two solutions to this quadratic are 4/3 and 1/2. All right, let's look at another one. We have 3x squared minus 4x plus 6 equals 2x squared plus 2x minus 2. We got to get it in that form again where everything is on one side of the equal sign and 0 is on the other. So I'll subtract 2x squared from both sides, 2x from both sides, and add 2 to both sides to get x squared minus 6x plus 8 equals 0. So then we'll factor this. If it factors, it'll factor into two groups of 2, and we're going to need two numbers that multiply to get positive 8 that add to negative 6, which is negative 4 and negative 2. We'll set each of those factors equal to 0 and solve separately, and we see that this quadratic also has two solutions, positive 4 and positive 2. Let's look at an application problem. A tennis ball is thrown into a swimming pool from the top of a hotel balcony. The height of the ball from the pool can be modeled by d of t equals negative 16t squared minus 4t plus 300, where t is the time in seconds. How long does it take the ball to reach 144 feet above the pool? When working on word problems, sometimes it's easier to draw a picture. So pretend like this is your hotel and here's your balcony on the roof. Why not? We're throwing the ball here. This hotel is 300 feet above this pool right here. And so I'd guess right about here is about 144 feet. And I want to know how long does it take till the ball gets to this point right here, this moment. Well, if at this moment it's 144 feet above the pool, and d represents its height above the pool, so I'm looking for when d of t is equal to 144. So I will take this equation, that negative 16t squared minus 4t plus 300, and set it equal to 144. We'll get everything on one side, so I'll add the 16t squared, add the 4t, and subtract the 300 to get 16t squared plus 4t minus 156 equals 0. Now I'll factor this. There is a common factor. Everybody here is divisible by 4, so I'll pull that 4 out. And then we'll go through our method of factoring this here, and when we do, we'll see that we get 4t plus 13 times t minus 3. So now we're ready to set our factors equal to 0. Well, 4 is a factor, but 4 doesn't have a variable, and 4 is never going to be equal to 0, so we just kind of ignore it. So we'll set the 4t plus 13 equal to 0 and the t minus 3 equal to 0. Here we'll add 13 and divide by 4. Here we will add 3, and we get two solutions, negative 13 over 4 and 3. But remember, t is the time in seconds. There's no such thing as negative time. Even when you're counting backwards, time is still moving forward. So time is one of those things that is always positive. So we can't have negative time. So that must mean we have to take this positive one, that it takes the ball 3 seconds to reach 144 feet above the pool. Now from our previous video with the lecture, we know there's another way that you can solve these quadratics using the quadratic formula. Still, first step is to get everything on one side of the equal sign, 0 on the other, so we'll add this 1 to both sides. And now with the quadratic formula, we've got our a, which is 2, our b, which is 1, and our c, which is 1, and we will plug it into that long formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll plug in 1 for b, we'll plug in 2 for a, and we'll plug in 1 for c. And as we start to simplify under here first, right, so this negative 1 stays as a negative 1, 1 squared is 1, and 4 times 2 times 1 is 8. Under there, that's going to give me the negative 1 plus or minus the square root of negative 7. The square root of a negative number is non-real. It doesn't exist in the real number system. It does exist in the complex number system, but our class we're sticking with the real number system for now. And so that is a non-real answer. So that just means that there are no solutions to 2w squared plus w equals negative 1 in the real number system. So let's look at this problem. The global spending on travel and tourism in millions of dollars can be modeled by y equals 6.75x squared minus 122.94x plus 1009.44, where x is the number of years past 1990. You'll see problems like this a lot. When you see something that says like x is the number of years past 1990, the way to look at it is x is your age and you were born in 1990. So if it's the year 2000, you were born in 1990, how many years past 1990 is that? You'd be 10 years old. So what year after 1990 will global spending reach $983.52 million? All right, well, Y represents the global spending in millions of dollars, and I want to know when that's going to be 983.52, so I'll take this equation and set it equal to 983.52. Just like before, we'll get everything on one side of the equal sign, 0 on the other, so I'll subtract that 983, and I get this. Now look at this. This is not something I personally would want to factor because I don't know how this would factor. If you do, by all means, try to solve it by factoring, but most of you probably won't be able to because it doesn't factor into nice integers. So to solve this, we'll use the quadratic formula. A is the number in front of the square term, B is the number in front of the singular term, C is the number that doesn't have a variable. So we see that A is 6.75, B is negative 122.94, and C is 25.92. So we will plug that into our quadratic formula, negative B plus or minus B squared minus 4AC all over 2A. When you try to calculate this, don't put this in your calculator in one full swoop. It leaves a lot of room for error if you don't put parentheses in the appropriate places. So we'll just simplify one piece at a time. A negative will become a positive. I'll go ahead and square this number, and I'll multiply the 4 times A times C. Now under here, we can go ahead and subtract these two values. And then I can go ahead and take the square root of this big value here. And I get x is equal to 122.94 plus or minus 120.06 all over 13.5. There are two solutions here. The solution where you take 122.94 plus 120.06, and the solution where you take 122.94 minus 120.06, both still over that 13.5. So individually, I'll add the two to get that numerator, divide by 13.5, subtract these two values and divide by 13.5, and I get two different solutions. Now remember, x is the number of years past 1990, and I want to know what year past 1990. Well, here, this is less than 1, so it hasn't even been a full year yet, so we're not past 1990 here. Here we are, 18 years later would be 2008, so the global spending will reach 983.52 million in 2008. That's it for now. See you next time.